Hi, my name is Aubrey Goff, and this is my Lab04 oscillation. So for this experiment, I modeled the motion of a spring mass system using Python and compared it to a real-world motion video that was given to us. So let's start with comparing the predicted and observed motion. So I'm going to go ahead and run the program. And I'm going to choose the file that has the X and Y coordinates for the real world example. So looking at the position graphs first, X position and Y position, the blue curves represent the model predictions and the red curves represent the real world tracking data. So we can see that they similarly follow the experimental data, but it includes small deviations that are probably caused by external factors, like where I place the the center mass point within the actual computation, air resistance, a misalignment of the real setup, any small inconsistencies or anything like that. But to improve the accuracy, I included the initial position and initial velocity from the first few frames of the real life data. Now, looking at the energy principles and the changes in kinetic energy are in blue, gravitational potential energy is in red, spring potential energy is in green, and total mechanical energy is in orange. As expected in an ideal system, the total energy stays pretty constant, which confirms that the energy principle is satisfied. And the small fluctuations in total energy are likely due to numerical rounding or approximated values or anything like that. But the individual energy components like kinetic, gravitational, and spring potential all oscillate as the system moves, and the sum remains pretty constant. So the close agreement between the predicted and the observed motion validates that this model is accurate and can be implemented. It's accurate using Newton's second law, and the spring and gravitational forces accurately represent the dynamics like we would see in a real system. And the fact that the total energy conserved in the simulation confirms that the energy transferred between kinetic and potential forms isn't being lost due to friction or air resistance, and that's all within the limits of the model. But if we wanted to make it closer to a real life example, we can include dampening forces or nonlinear spring behavior or anything like that. So to measure the oscillation periods, we would measure the time between peaks. And the values are nearly identical, which is expected since the motion is governed by the same spring force in both directions. So the small differences could be due to a projection angle or a misalignment in the tracker video, again, which could be just attributed to human error. But to summarize, the simulation here successfully replicates the motion of a real spring mass system that was captured on video, and the energy principle holds throughout the motion, and the estimated oscillation periods from both the X and Y directions support this model's accuracy. Thank you so much.